As the 21st century began, the global strategic landscape had shifted significantly. With the Cold War over and traditional threats like the Soviet Union fading, asymmetric warfare, regional conflicts, and urban littoral operations came to the forefront. The U.S. Navy, long accustomed to blue water fleet strategies, recognized the need for a radically different type of warship. This led to the launch of the DD-21 program, an ambitious effort to create a next-generation destroyer, stealthy, capable of delivering shore-based fire support, and optimized for near-coastal operations. The project was later renamed DDX, eventually evolving into the Zumwalt-class destroyer, named after Admiral Elmo Zumwalt, the visionary leader who spearheaded sweeping reforms in the Navy during the 1970s. 1. Design. When form defies convention. Unlike most modern warships that feature outward flaring hulls for greater stability, the Zumwalt uses a tumble-home hull where the sides angle inward above the waterline, forming a truncated pyramid shape. This design, largely abandoned since the 19th century due to poor performance in heavy seas, was revived for one reason: radar stealth. The tumble-home shape deflects radar waves away from their source rather than bouncing them back, dramatically reducing radar cross-section (RCS). As a result, despite being over 600 feet long and displacing more than 15,000 tons, larger than a cruiser, the Zumwalt appears on radar like a small fishing boat. Additionally, the ship's sharp angles, from bow to deckhouse, are all designed to scatter radar waves, much like the F-117 or F-20 stealth aircraft. Fully enclosed structure, hiding everything to survive. Another key stealth feature is the ship's fully enclosed configuration. No exposed missile launchers or deck guns like those on the Yarlaberg or Ticonderoga classes. Radars and antennas are embedded within the composite deckhouse rather than protruding skyward. All sensors, weapons, and even auxiliary systems are concealed in the hull or the sleek deckhouse. The ship's weapons are housed in peripheral vertical launch systems (PVLS), placed along each side of the hull in enclosed compartments. This layout not only enhances stealth, but also improves survivability, and explosion on one side won't compromise the systems on the other. Wave-piercing bow, cutting through rather than riding waves. Zumwalt features a revolutionary wave-piercing bow, designed to slice through waves rather than ride over them. This stabilizes the ship at high speeds, reducing vibration and increasing the accuracy of long-range precision weapons like the AGS or cruise missiles. However, this design comes with trade-offs, especially decreased buoyancy and stability in rough seas. Room to grow, built for future upgrades. Displacing over 15,000 tons, Zumwalt has vast internal volume. Its systems, cooling, energy, and electronics are over-engineered to accommodate future weapons and technologies that other warships can't host, including electromagnetic railguns, high-energy lasers, and next-gen radars, AI-integrated combat systems, and network-centric warfare modules, hypersonic missiles requiring larger launch tubes. In essence, the Zumwalt is a modular, future-proof combat platform ready to host tomorrow's naval technologies without the need to build new ships.
2. Power system, the electric heart of a future warship. While Zumwalt's hull makes it stealthy, its power system is what makes it revolutionary. Acting as a floating power plant, it's designed not only to propel the ship, but also to power next-gen weapons and sensors previously considered science fiction. Integrated Power System (IPS), all-electric propulsion. Unlike traditional mechanical drive warships, Zumwalt is the first U.S. Navy destroyer to use an all-electric propulsion system. Two Rolls-Royce mount 30 gas turbines, each generating 4 megawatts, don't drive the propellers directly. Instead, they generate electricity distributed across all ship systems, from propulsion to radar, weapons, cooling, and electronic warfare. The ship produces a staggering 78 megawatts of electricity, enough to power a small city of 60,000 homes. This is unprecedented for a destroyer. Unlike traditional ships, which must balance power between engines and weapons, IPS allows Zumwalt to redirect energy as needed. During slow movement or idle periods, power can be shifted to radar, missiles, or lasers, offering unparalleled tactical flexibility. Its electrical output enables deployment of energy-intensive systems. Railguns, using magnetic force to launch projectiles at Mach 7, no explosives, extremely fast, highly destructive. High-energy lasers, to shoot down UAVs, cruise missiles, or suicide boats, requires constant, clean power easily supplied by Zumwalt. Powerful phased array radar, capable of detecting stealth threats, ballistic missiles, and hypersonic projectiles. With no rotating drive shafts, electric propulsion significantly reduces mechanical noise. This makes Zumwalt harder to detect via passive sonar, an essential advantage in coastal or submarine-heavy environments. The IPS is modular and highly automated, allowing quick replacement of faulty parts, and enabling the ship to operate with a lean crew of just 140 sailors, less than half the size of comparable destroyers. Despite its promise, IPS comes with major hurdles. Integration complexity, synchronizing electrical, control, and backup systems requires extreme precision. Any failure can cripple combat capability. High dependency, if the power grid goes down, the entire ship is paralyzed. Extensive fail-safes are required to prevent blackouts. Costly upkeep, advanced tech requires specialized parts and personnel, raising maintenance costs and complexity. 3. Sensors and combat control. A smart brain at sea. Zumwalt is the first destroyer equipped with a total ship computing environment (C), integrating all shipboard systems into one unified computing platform. And Spy-3 X-band, high-resolution radar for low-flying targets and stealth detection. Spy-4 S-band, initially planned, long-range radar for ballistic missiles and high-altitude threats cut due to budget constraints. Together, these systems enable Zumwalt to detect and engage targets from hundreds of kilometers away, even in heavy electronic warfare environments. 4. Weapons ambition meets harsh reality. Zumwalt carries both high hopes and hard lessons about the limits of military innovation. One of its most hyped systems is the 155mm Advanced Gun System (AGS), originally hailed as the most advanced naval artillery of the 21st century. It was meant to use long-range land attack projectile LRLAP rounds, accurate to within meters, at 110 kilometers range, bringing offshore artillery support to ground troops. However, the cost per LRLAP round ballooned to over $800,001 million, making mass procurement untenable. The program was scrapped, and AGS can't use any alternative ammo, rendering it functionally useless. Today, these cutting-edge cannons are little more than expensive hood ornaments, a painful example of over-reliance on unproven tech. Fortunately, Zumwalt's primary firepower comes from 18 MiG-57 vertical launch system VLS cells along both sides of the hull. This layout minimizes collateral damage from potential hits and enables a wide array of missiles. Tomahawk, long-range land attack. SM-2 and SM-6, long-range air defense. RIM-162 ESSM, short-range missile and aircraft interception. ASROC, anti-submarine torpedoes. In the near future, Zumwalt may also deploy the conventional prompt strike CPS hypersonic missile, capable of striking anywhere on Earth within minutes. This would transform the ship into a true strategic strike platform, one that replaces traditional artillery with speed, precision, and global reach. Zumwalt is a bold symbol of naval innovation, but the gap between revolutionary intent and battlefield readiness remains real. Unstable hull. The tumble-home design compromises sea stability, especially in rough weather, making the ship harder to handle. Useless main guns. The AGS cannons are non-functional due to the lack of viable ammunition. Poor close-in defense. The ship lacks a CIWS like the phalanx system, leaving it vulnerable to cruise missiles or drones at short range. Massive cost. Limited impact. At $7 billion per ship, only 3 Zumwalts were built, making logistics, training, and support highly inefficient. The Zumwalt-class destroyer is proof of the U.S. Navy's radical push for innovation. It may not be optimized for today's warfare, but it's a launchpad for the future of combat where stealth, AI, hypersonic weapons, and directed energy converge. The Zumwalt may never see full-scale combat, but its technological legacy will live on in destroyers, cruisers, and possibly even the aircraft carriers of tomorrow.